Everybody, I hope you all are doing great. So in this video, we'll look into a very interesting topic, that is mTLS with SPIFFE. Okay. So regarding mTLS, I have already made a detailed video. The link to that video, you can find it in the description. So now in this video, I will again give an overview of what is mTLS, but our main scope of this video will be the deep dive of what is SPIFFE, Spire and its related components, and also look into a practical demonstration of how do we use these components. Okay, so we'll start with the introduction of mTLS, then we will move into what are the limitations, like why we needed to develop the SPIFFE. Next, we will discuss deeply into what is SPIFFE, what are its components, and how do we integrate that into a distributed architecture, right? So then I will show you the practical demonstration. Okay, so let's get started with the introduction to the mTLS. Start with the introduction to mTLS. Let's take a simple example. So in this example, we will see how a loan request is processed, and in that we will see the role of mTLS. Okay, let's say you need a loan, and you went to your bank's website and you added a couple of details which the bank website will ask, like user ID, name, and the loan amount. Let's say you added those details and submitted the loan request. Now that request will be served by the loans backend server. Okay, so the loans backend server has received this request, and then it will process that request at its end, but there needs to some extra processing, like it also needs to check the CIBIL score, right? As you know, for getting a loan, the CIBIL score is checked, but as you also know that the CIBIL score is not maintained by the bank. So CIBIL score is actually maintained by some other external agency. So to now get the CIBIL score of yours, this bank server needs to make a call to the another server to get the data, right? But now, as you can see here, the bank server is in their own VPC. What is VPC? VPC is like their own boundary of network. So to give a simple analogy here, if this server, whatever the CIBIL score server is there, if this server was within their VPC, then it's like communicating between two friends. So when you communicate with your friend, there is no trust issue. Like you trust your friend, you can make a communication or you can make any transaction. But here, this communication is like talking to a stranger. So here, this CIBIL score server is outside of the bank's network. Okay. So now comes the trust issue. So what is the issue here? How does the bank server trust this server, and and when this server gets a request, how does this server should trust this server, right? Because anyone can make a call to any server when they are in the network. So how does that trust should get established? When you are within a network, then the chance of like the communication becomes easier, but when you are outside of some network, then the communication or the trust becomes the issue, right? So this is where the mTLS comes and resolves the issue. Now let's understand that how mTLS is established between the bank server and the CIBIL score server, and then the data, how the data is getting exchanged. So to understand mTLS, let me move here. So here we'll be discussing mTLS without SPIFFE. Okay. After this discussion, I will discuss what are the limitations of mTLS and how those limitations are solved using SPIFFE. Okay. So this is the main objective of this video. So now, what is mTLS or how it is established? So for this, the first component that is needed is the certificate authority. So what is certificate authority here? It's like the RBI, right? In India, we have an RBI, or in other country, there may be some other institutions who will give a guarantee to some transaction. Let's say we are transacting or we are exchanging some goods and service in return of a currency, right? So that currency had some value because the RBI has signed on it, right? It has given that guarantee, right? So exactly same thing, we need a guarantor who will issue some certificates. Okay, so using those certificates, mTLS is established. Okay, I hope this simple point is clear. mTLS is basically established using the certificates. So what is the process? Let's understand that. So here, first, let's say we have a certificate authority, like I hope you have heard these names like GoDaddy, Let's Encrypt. So if you have not, then you can just do a small research on these things. What are these? But for now, let's understand this like it's an authority. where you can go and get the certificates. Okay, so as I said in the beginning, I have already recorded another video on this mTLS, like how to create the certificates and all those things that you can watch over there. But here I'll just discuss the theoretical part of it, and practically I will only be showing the SPIFFE part. Okay, I will not be showing the mTLS part in this video practically. Okay, yeah, getting back to here. So you will go to certificate authority. There, first step what you will do, you will just generate a private key, and using that private key you will generate a certificate. Okay, so let's say the public certificate is generated and it is ready. Okay, and this is the bank's certificate authority. Okay, so you got the public certificate. Now the same thing the CIBIL score server or CIBIL score agency will do with its certificate authority, and let's say they are using let's encrypt as their certificate authority, and they will also just generate the private key, and using that private key they generate a public certificate. Let's say their public certificate is also ready. So we have two public certificates of two different CA authorities for different organizations. Now comes the question, like how is this used? Okay, so to use these certificates, we also need some other steps to be completed. So let's say now first the bank's microservice, what it needs to do? It needs to do three steps here. The first is it needs to generate a client key. Okay, it's nothing but a simple bytes of values, like a longer value, like which will be generated as a key, and using that key a next file is generated, that is client.csr. So this is nothing but certificate signing request. So this is an intermediary file that will be signed using this certificate. Okay, so using this public certificate, the client.csr gets signed, and finally you will get client.certificate. Okay, so in nutshell, you need to just remember two certificates per server. First one is a public certificate from the certificate authority, and the server certificate, that is client.certificate. Okay, now coming to this part, coming to CIBIL score. Now what the CIBIL score will also do, they will also they will first generate a server key, and then they will generate a CSR will get signed with the public certificate from let's encrypt, and then finally they will get the server.certificate. So now this server will also have two certificates. Okay, I hope till this point the things are clear. Now both the organizations have their own two certificates, right? Now comes the deal part. So now what this bank will do, this bank will go to this agency and they will do a deal that, hey, I need your service. So once they do the deal, at that time what they do, they will manually, like I'm saying manually, but technically what they will do, they will just exchange the certificates. What do I mean? Like this bank will give its public certificate to the CIBIL score, and the CIBIL score will give its public certificate to the bank. Okay, so now this is the third step. First step, we generated the certificate from C authority. Second step, we generated our own certificates. Now the third step, when the deal is done, at that time these two people or these two organizations will exchange their public certificates. Okay, now this has its public certificate, it has its public certificate. Okay, I hope till this point it is clear. Now comes the next part, the request part. Okay, so when this server is like bank service is sending a request to the CIBIL score, now how the mTLS is achieved, because here there is no trust, they need to establish the trust. So when the communication happens, or when the server receives the request from the bank, what the bank will do, hello client, like it will just say, I have received your request, it will acknowledge, and it will send its certificate. Okay, so let's say what will it will do, it will send this server.certificate to the bank. Okay, now along with that, it will also say that you also need to send me back your certificate to authenticate, right? Because both needs to establish the trust. So now once this client gets the bank's certificate, it will validate this using this CA.certificate with that they initially got it from the when they were doing the deal. So using that, it will validate this, And once it validates and it confirms that it is a valid certificate, what it will do? It will send its certificate for the validation to the CIBIL score. Now, how the CIBIL score will validate? At the time of deal, as you remember, it has also got the public certificate of the bank. So using this GoDaddy certificate, public certificate, it will validate this client certificate. Okay. So now at this point, the mTLS has been established. Okay. So now both have been validated using these certificates, and now the HTTPS or the TLS, transport layer security channel, has been established, and using that channel, the data will get transferred. So now how does the man in the middle attack is like prevented here? Because this man in the middle will not have these certificates. So though what he can do, he can tamper this, he can just hack this network, but now the data that is getting passed in this network is encrypted. Even if this man in the middle gets the data, he will not be able to read that because he will not be able to decrypt. Okay. So in the another video, I have deeply discussed what are the packets they will be exchanging and everything I have discussed. You can just watch over. But this is a high level overview about how the mTLS is established and how the communication is happening. Okay. So I hope till this point it is clear how the mTLS has been established and how the communication has happened. Now next we'll see what are the limitations in this architecture, like where the mTLS is not suitable, and then we'll see how the SPIFFE will like help us to avoid those limitations. Okay, let's look at the couple of limitations of mTLS. So here in the limitations in this table, if you look, the first limitation is the identity issuance. So what does that mean? So with plain mTLS, which we have just discussed, what we needed to do, so here you must manually generate and distribute the certificates for every client or server. So I hope you were able to relate to this. So what we did, so we manually generated the certificates with the certificate authority, and then put those certificates into the servers for the achieving the mTLS between the server and the client. All right. So this thing can be automated, or like we'll be seeing that next, will be automated using the SPIFFE. So with the SPIFFE, it will be issuing a short-lived SPIFFE verifiable identity documents. These are like same certificates, but these will be automatically created and will be distributed. So that is the first issue which the SPIFFE will be solving, okay, in comparison to the mTLS. Next issue is certificate rotation. So once the certificate is generated and we keep them with the servers, so those certificates comes with some expiry. Okay, usually manually when we generate them with a very long expiry date. So there comes the issue of security, right? If those certificates gets if they gets into the wrong hands, then they can be misused, right? So these are the two reasons. One, we will be generating a long-lived certificates using plain mTLS, and when it expires, we needed to manually again renew the certificates. So these both the things can be resolved using the SPIFFE. So the SPIFFE will generate the certificates. They are short-lived, and also before they get expired, it automatically gets renewed. So it's highly loosely coupled. So from the server side, we do not need to worry about the certificate management. It will be everything will be done by the SPIFFE. We just need to use those. Okay, so that's the second point. Third point here is bootstrapping trust. So what does that mean? So you must pre-share the CA certificates and manage trust bundles yourselves. What does that mean? So let's say we do not, let's say, just consider within our architecture. Okay, so we will not go with the other architecture. Within our architecture, let's say there is one loan microservice, and let's say there is another microservice within our own network, let's say customer. So now within these two servers also, when we want the communication to be highly secured, then also in that case we will be going with mTLS, right? So when we go with mTLS, now these steps which we discussed here, we needed to bootstrap. Like what does that mean? We needed to rotate these certificates manually for all the servers, right, which are there within our network also. right? So this is again a pain process. So again, this can be, the bootstrapping can be automated using the SPIFFE, right? So these, okay, where do I left those? Okay, yeah. So we have it here. So that's the bootstrapping trust. Now the third point here we have is the dynamic workloads. So here with the plain mTLS, what we are doing, we are generating certificates and we are like adding it into our required servers. So let's say, so today I have only these two microservices and I generated it from the CA authority and I just put into them and I'm using it. But tomorrow, let's say I need to increase the number of microservices. Let's say I have different microservices for different purpose. And in that case also, I again need to do the same process for the new services, right? There is no automation that will just automatically pick those new certificates and put in and can be used for the new servers or the new microservices. So this is again automated using some like a topic or a concept called as workload management. So with the SPIFFE, we will be creating the workloads. So those workloads will be mapped to the new microservices automatically. So we do not need to worry about again the certificates when new services are created. Okay, I hope you are able to get this fourth point. What is dynamic workloads? Next, the final point and the most important thing which we were discussing in the previous example, that is cross environment trust, right? So now comes the things which we were discussing, that is when we want to establish mTLS between two different organizations, right? So in that case, how do we make sure? So here there is, if you remember, here we were having a common thing, that is a public certificate from the CA authority, right? So using those public certificates, we were able to like validate the each other certificate, and also we were signing those certificates. So this public certificate was the root, right? So this can be automated, or this will be taken care by the SPIFFE, and both the organizations just need to registered with that centralized server. So that we called as federated spire architecture. So what does that mean? So we'll be having a federated spire server. So with that the federated spire server will be distributing that public certificate to both the organizations. So like both organizations need to register with that, and that will take care of those like cross organization certificate management. So I will be discussing this topic in the upcoming next video. I will be here in this video. I will be discussing only about the setup of the Spire and SPIFFE, like overall architecture. I'll just show you how we can automate everything, and for the like between the organizations, how to manage that comes under federated architecture of SPIFFE. So that I'll be discussing in the another video. Okay, yeah. Coming back to our last point, that was the cross environment trust, where we needed to manage by ourselves. Like if you remember, we when the deal happened, like we like exchanged the public certificates between our two organizations. But this exchange of our certificates can be automated using the federated architecture that I'll discuss in the next video. Okay, yeah. So before that, we'll discuss these four how we can overcome these first four limitations. The last limitation I will be discussing in the next video. Okay, so next I will show you the flow of or the components that we'll be using in the SPIFFE. Okay, so let's discuss the SPIFFE architecture. So what SPIFFE basically stands for? It stands for Secure Production Identity Framework for Everyone. So what SPIFFE here is, it's nothing but a protocol. So the way we have HTTP or HTTPS protocol to communicate between the client and server, and then we have different protocols to communicate between different kinds of databases, right? So similarly, to move or rotate these certificates in this architecture, we will be using this SPIFFE protocol. Okay. Now to implement this SPIFFE protocol, we have something called as Spire. So Spire is nothing but a runtime environment of this SPIFFE. So Spire provides us with all those components which we'll use to implement the SPIFFE protocol. Okay. So I hope you're clear with what is SPIFFE and what is Spire. So in the Spire, we have different components. So let's start with the first one. So the first component here we have is the Spire server. So the role of Spire server is exactly same of what the certificate authority was doing. So the CA was issuing the certificates and renewing the certificates when they were about to expire, right? So, but that was manually, and here exactly the same thing is done by the Spire server. It is going to issue the SVIDs, not the actual certificates which we are using, because now this comes under the SPIFFE protocol. So according to the protocol, here we'll be using SVIDs. So SVID stands for SPIFFE Verifiable Identity Documents. So these documents we'll be using to establish the mTLS. So the underlying concept remains the same. Only the nature of the file gets changed. So there we are using .crt certificate kind of files. So here we'll be using SVIDs. Okay, I hope that makes sense. So coming back to the component, so this is Spire server that will be we'll be deploying it as a separate server that will be helping us with this certificate managements or the SVID managements. I hope you are clear with the Spire server. Next component we have here is the Spire agent. Okay, so now what is an agent? To understand this with an analogy, so agent is like the dealer. Okay, let's say you want to buy a car. So when you want to buy a car, you don't directly go to the manufacturing unit or the factory, right? You'll go to a dealer, there you will book a car and the dealer will deliver you the car, right? So exactly like same thing here. This Spire server is like a manufacturing unit where the certificates or the SPIDs are generated, and the Spire agent are like the brokers or the dealers who will be like getting those certificates, and then they will be passing down to the downstream systems. So this is exactly what the role of the agent here. Now comes the next important question, like what will be the role of, or is the relation between the agent and our services? So here ideal, so I'm like what I'm talking here is the ideal situation, how ideally the things should be there, but according to the different production requirement or the different organization requirement, the things may change, but the concept remains the same. So now what the ideal situation is here, every like for each service or each microservice there should be one agent. So what do I mean? Let's say we have a loan microservice, right? We discussed we had a loan microservice. So here this, let's say this is a loan microservice, loan MS. Okay. So let's say all these three instances are of the same microservice. We for high scalability, what we did, we just created three instances of same microservice. So in this case, we should have only one agent for loan microservice. So though we may have hundreds of same instances, okay, but let's say we have different microservice. Let's say I change it to customer, and let's say I change this to bank. So now we have three different microservices. So in this case, we should have three different agents. So this is the ideal condition which should be followed, but this can be changed according to the requirement. Okay. So now let's assume that this is one microservice, that is loan. Okay. So now for one of the microservice, we will be having one agent. Now how does this agent and the microservice will communicate? Okay. So for that, we will be having the next component, that is the Spire helper server for the microservice. So now what is the role of this? So the role of this is to get those certificates and put it into the key store. And why do we need it? Why do we need this middleman? So the concept here is like this agent and the Spire server are like the platform agnostic, or you can also say the language agnostic. So you can just use it in any of your backend architecture. It may be running on Java, Python, Node, or whatever your backend architecture is. You can just spin these two. It will not have any effect. But if I'll be discussing about Java, specifically Java architecture or Java environment. So Java or the Spring understands the P12 format, right? P12 key store format. So now we need the files in those formats. So we need some conversion or some helper in between which will convert these SVIDs into P12 formats. So that the role will be like completed using this Spire helper client, or this is for the client, so I have added it as a client, and if it's for server, I have added it for server. So let's say let's consider it as a Spire helper. So this Spire helper will be making a internal call to this clients whenever the certificates is needed. So it will just get the certificates and it will put into the key store. Okay. So right now I'm just discussing about the role of each component. The flow I'll discuss later. Okay, so let's just try to understand the components first. Now, what is the role of the key store? So key store is the where the files will be generated, and once we spin up the microservice, they will, like at the runtime or the moment when they are getting started, they will pull those certificates and it will be saved in those memory. Okay, and then those will be used for the like come or establishing the mTLS. So now I hope you are clear with the different components here. What is the role of agent? Agent is to get the certificates and like keep it with it. Then helper is to get the certificate from the agent and convert it into the format which the underlying services will understand. And key store is where the final certificates will be stored. Okay. I hope these things are clear. Component, I would not say it is a component, but it is a step or the process that we need to do. Okay, so that is the workload registration. So this workload registration is a step that we need to implement to complete this whole process. So what do we mean, or what is this workload registration? Let me just take an example to help you understand that. Let's say you want to book a movie ticket. So to book a movie ticket, especially in India, you have multiple options, like multiple platforms where you can just go and book the ticket, like Book My Show, Paytm, right? So if you book a ticket on these platform, and then when you go there to the theater or the movie place, so there you will just show the digital ticket and get the physical ticket, and you will enter the cinema hall, right? But let's say due to some reason or like you are not aware, and what did you just went to Google and just type book ticket, and just accidentally you opened a fake website, a suspicious or a malicious website, and there you found that you are getting an option to book the ticket. So you just went ahead and booked the ticket. Now you have the digital ticket, but when you go to the theater and just show that ticket to enter, they'll just reject that, because the ticket with where you booked, it was a fake website, it was a malicious website that nobody knows about it. So what I basically mean here is, you can book the movie ticket only on those platforms which are officially registered with the theaters, right? Which are officially publicly known, right? So if you book some tickets in some of the platform where it is not known or it is not registered, then that's of no use. So that's exactly what the workload registration is doing here. So what basically it does, so with the help of workload registration step, what we do, we tell the server that to which agent or to which helper or for which request it needs to issue the certificates. So what do we do here? We like register with the server regarding the agent along with the some other details, so that when this helper asks the agent for a certificate, then the agent will go and check with the server, hey server, I need certificate for this helper. Okay, in that case, now the server will check whether there is some registration for this request or not. Okay, so if the registration is there, then the server will return back the agent with some certificates, whatever the requested was there. But let's say if this workload registration step was not done, okay, and in that case the agent comes and asks the server for some certificates, and server will check for the registrations. If it found that there is no registration, then it will just return back saying that, hey, there I can't issue the certificates as there is no registration. Okay, so I hope you able to understand this critical step. So workload registration is nothing but we are registering some things with the server that will help the server to validate the requests coming from these clients. Okay, so now let me just summarize the whole flow, how this flow happens, or what are the steps we need to take to implement this in the system. Okay, so the first step we need to do is to spin up the Spire server. Okay, so once the server is started, we need to create a token, an identity token we need to create for each agents. Okay, so along with the token, we also need to create the next thing, that is the bundle of certificates. So these bundle of certificates are like the root certificates that will help the client and server for validating the certificates which they get from each other. So it is exactly the same thing what we were doing in mTLS, where we were getting the ca.certificates from each certificate authority that we are keeping with all our known servers, right? We were having ca.certificate here also and here also. So those were helping us to validate the request. So exactly the same thing here also. The server will give us some certificate known as bundle.crt. So that bundle of .crt needs to be generated from the Spire server, and that needs to be kept with every server. Okay, so this is a step, or this is a thing which is the only manual thing which I will be showing, that is creating the bundle of certificate in this video. Okay, but this can be automated, which I already discussed in this step, that is cross environment trust, using the federated architecture of the SPIFFE. So using the federated architecture, this generation of the bundle dot certificate can be automated, and we do not need it to do any manual step. But that's a part of another video, that's another concept. So for that reason, that one step we need to do it manually, and we need to put it manually in the key store. Okay, not in the key store, but where the agent can able to get those certificates. Okay, so that's the first step. First step is to generate the bundle dot certificate from the Spire server, and the next step will be to generate the token. So each token will be generated for each agent. So that is a one-time token. So once it is generated, we cannot like reuse again. It can be used only once. And using that token, I will register my agent with the server. Okay, so these are the two steps completed: creating the server, creating the agent with the token. Now, this once the agent is created, agent will be created within each machine. Okay, so once it is created, it will expose a endpoint that will be an agent.sock. So that's a protocol on which, that's like it's a port on which we will be able to communicate within the system without the need of the network or the internet. So within the system, the systems will communicate over that agent.sock, and that will be a kind of port that will be exposed by this agent. Okay, so after that we need to spin up our Spire server. So before spinning up the Spire server, we need to take this step, that is workload registration. So first step is to create the server, second step is to create the agent, third step is to like register that workload. Okay, so once the workload is registered, then we need to spin up the Spire server. So once the Spire helper server is spinned up, it will make a call to the agent to get the certificates. So then the agent will make a call to the server to get the certificate on behalf of this Spire helper. So now the Spire server will check that whether there is a registration or not. Yes, so registration will be there, and it will return back the certificates. Those certificates will be pulled by the Spire helper, and the helper will just convert those certificates into the format which our underlying applications will understand, and it will put it into the key store. And from here, the certificates will be used by these key stores to communicate with the other services. Okay, I hope you are able to understand this process. See whether the limitations has been addressed or not. So the first limitation we had is the identity issuance. So here with the plain mTLS, we were depending on like ourselves to like generate the certificates from the CA authority, then putting them into the server, right? But here now the Spire server and its related components will be doing that heavy lifting. We just need to like connect to the key store and pick the certificates, and we just need to reload it. Like it will, the application will automatically reload when there is some change in the key store. Okay, so that's the first limitation has been addressed. Second limitation we have regarding certificate rotation. So whenever the like it now the Spire server will automatically take care of renewing the certificates and removing the old certificates. Okay, so the second limitation also taken care of. Third is the bootstrapping trust. So when let's say now right now I have taken example of loan microservice. Now let's say I need to spin up the another microservice, and for that also if I need the certificates, I just need to rely on the key store. I just need to attach my like provide the location of the key store in my application, and it will just pick it up. because the other heavy lifting of creating certificates and other things will be taken care of by the server. Just I need to create a workload registration, that is important. Okay, so this must has to be a manual process, right? Because somebody must be there to tell like how which certificates or how many certificates we need. So this step definitely will be, we need to tell to the server like which for which microservice it needs to generate the certificate when it gets a request. So when we like spin up the service, it will automatically get that from the key store. So the bootstrapping trust is also you can say automated, or the process has been reduced. Now we just need to do one step, that is workload registration. Next we have the dynamic workloads. So here, as we already discussed, let's say if there are some service that goes down, and if I just spin up the next service, then I do not need to configure anything related to the certificates. So the moment it will spin up, it will just get the keys or the certificate from the key store. Okay, so that dynamic workload has been now offloaded to the SPIFFE architecture. Okay, and the last point, that is cross environment trust, that is related to the bundle certificates. So the bundle of certificates which the SPIFFE server will issue at the in the initial point, which forms the root of the whole authentication or the TLS process, is still manual in this architecture or in this discussion. So but that can also be automated, as we have already discussed. Okay, so overall the first four limitations has been addressed. We'll be trying to address the last limitation in the another video. So next, let's look at how do we spin up these services, how do we map them and able to achieve our objective. Okay, so let's get started with the configuration part that will help us to spin up the required servers and the components. So to get started with a fresh, so like we'll start with the creating a separate directory, and in that directory we should also go ahead with creating the other necessary directories that are needed for the containers. Okay, so these steps are not mandatory, these are optional, but we should like it's recommended to go ahead with creating this, because if we allow the container itself, the Docker itself, to create this when the container runs, then it will create the directories, but there can be some permission issue that may cause issue to start the containers. Okay, so we'll just go ahead with creating the required directories by ourselves. So just go ahead with creating the Spire data directory that will help the server to store all its data in this directory. Then we need the Spire agent. So this is for the agent. So like the number of agents we create, so those number of directories we need in a temporary folder. So like either you can go ahead right now, or you can just create it later on when you are creating the agent. Okay, so let's discuss the important thing, that is the configuration of the server. So we need to create a file, server.configuration. In that file we need to add this configuration. So here the first part is, the first thing here we have bind address, that is specifying like the inbound traffic. So basically we with this we are telling that any agent can connect to the server for the registration. Then we have bind port, we are like where the server will be running, then the data directory where it will store the data, then the trust domain. So here the domain, like the organization for which we are creating this server, so that domain we need to add here. Then we need some plugins, so whatever the keys and the certificates which the server will generate, so to store that it needs a in-memory database. So here we'll be using SQLite 3 as an in-memory database, and that plugin we are adding here. Next we need a node attester. So this is, we are telling the server that like whatever the agent which will send a request, it should send a join token. Okay, so that will form the attester. So that configuration we are sending, if instead of join token, if it is sending something else, then it will not be able to register. Okay, then we are telling where should the keys should be stored, that will be in the in memory. This is just for development purpose I'm showing you, but for the production environment this should be connected to a separate database, because if the server goes down, then the keys and the certificates will remain safe, and the new server will just pick it up, whatever the existing data will be there. Else if you go with in memory, if the server goes down, then the whole memory will also go down, right? So now this is the configuration part. Next we will use that config file to run the Docker container that will run the server. So this is the Docker command. Here the name of the server, then the network. So we'll be using a separate network for all these components to run. So here I have not shown you the network command. So you can run a network command with this name, and inside that network we will run all our data, all our containers related to the SPIFFE. Okay. Here we are exposing the port over which the container will start. Next, we are telling the where is our server.configuration file right now. So here in these volumes, the -v tells us that how the volume is mounted, how the like directories are mounted. What do I mean? So this colon separates like the left hand side of the colon. This part tells the host directory, host location, and this tells the location of the container. So in my host, the configuration file is at this place, and that will be mounted inside the container at this place, so that the server should start. So similarly, we have these things. Then finally, we have the image with which we will start this Docker container, and then we are running the container with this configuration file at this location. Okay. Next, we need to start with creating a token. So the number of tokens created is equal to the number of agents we need to create. So as we discussed, we need one agent for one kind of a microservice. Okay. So let's say now we have two microservices. One is acting as a client, one is another acting as a server. So for the server, I'm generating this token. So I'll be using this token later on for the registration of those agents. So we'll generate these tokens two. One is for client, one is for server. Then we need to configure the agent part. So the agent server agent dot configuration we need to do. Similarly, we need to do client agent dot configuration. I'll just discuss one that is same in for the other also. So here in the agent, we will specify the data directory where it needs to store its data, agent's data, log level, then server address. So here I'm using host.docker.internal. So when you are on Mac, so you can just use this. That will help the container to connect to the other containers within the system. Okay, so this configuration may change according to different operating systems. Those are that you can just check out. For MacBook, you can just or Mac operating system, you can go with this. Okay. Next, for the server port, we are telling where the server is running. Socket path. So here it will mount this agent.sock as a file. So that file will act like you can say an API or internal for internal communication. So over this socket, we can the helper will connect to the agent, and this socket is like network. Like we do not need any network or internet to connect. Within the same machine, these the helper and the agent can communicate with this socket. Okay, so that's the location of the socket we are telling. Next, we have trust bundle path. So here we are telling to the agent where it can find this bundle of certificate. So I will show you how when we will generate the bundle in the next step. So here, this is the location of the bundle certificates. That is the root of the whole authentication system. Next, here we have trust domain, which we already provided. Then the join token. So join token, which we have generated here, that I am adding it over here. Okay. Next, the same, we have the plugins. So node attester, again it will be the join token. Key manager, again it will be the memory, and workload attester. So this workload attester is like a selector. So when we create a workload for a specific microservice, in that we need to tell the selector. So here the selector type is Unix. Okay. So I will come back to this later on. You can just remember for this moment. So this is the configuration part. So for the agent, so we have I have configured it for both for the client agent and one for the server agent. Next, we need to create a bundle certificate, which we have mentioned over here. So here we are telling that you will find the certificate at this place. Okay, so that's the same thing we have mentioned over here. So once the certificate is created, next we are ready to start the agent containers. So first we have started the server container. Now let's start the two agents. So first we have Spire agent for server, which will be running inside the same Docker network on the host, current host. Next, here again the volume mounting. So here we are telling that currently this file is at this location, that needs to be mounted at this location. Similarly, the same thing for the bundle.certificate. Next, we have SPIFFE data server where it will store the data. Then SPIFFE data agent server where it will store the agent's data, and the SVIDs. So here this is a location where the certificates will be mounted by the agents that it will get from the server. Okay. Then from there the helper will pick it up and it will convert and it will put into the key store. Okay. So this is a location where the SVIDs will be present. And finally, this is the image through which we are running this container. And finally, the run command that will run the container using this agent.configuration. Okay. So same thing for the client container, client agent container. So once we are done with this, we have 3 containers running. One is server, one is 2 agents. One is client agent and one is server agent. Okay. Next, so till here we are done with the first step. So next comes the workload registration. I hope you already know what is a workload. I have already discussed. So here we register the workloads. To register the workload, we need to tell that SPIFFE ID. So this is a SPIFFE protocol which we are using to communicate. So over this protocol only the communication will happen between the client, helper and the helper, agent and the server. And this is a parent ID. So here the parent ID is referring to the current, like the agent. Okay. So with that we will get this as the parent ID. Along with that we need to pass the join token. Okay. So this will help the server to recognize that to which agent it needs to respond, right? So here we are just registering a workload. Okay. But this will be used when the agent will make a call to the server to get some certificates. So here the very important thing is this selector. So in the selector we are selecting we are adding Unix and user ID as 0. So if any helper with a user ID as 0 makes a call to the server, then it will get back the certificates. So if any user ID with some other user ID, let's say 1 or 2, if agent makes a call, then it will not get back the certificates because we are registering a workload with user ID as 0. Okay. Along with that, it will also check these things, but this is the important. So same thing, one workload for the client and one workload for the server. Next comes the these are some commands that will help you to check the status of the above commands which you have run. So it will check the registrations. It will just give back the registrations. So this will give back you the whether the server is like giving the certificates or not. You can just test that. So if this test is successful, then you can be assured that when the agent will make a call, agent will get the certificates. Okay, so if you run this command and if you are not getting back the certificates, then when the agent will make a call, agent will also not get back. Okay, so that's a testing command that you can use. So till here we are done with the workload. Now comes the final step where we will configure the helper. So before we configure the helper, we need to configure the key store properties. So for that we need to create a .properties file. Okay, in the .properties file, add these configuration where is the key store path and then key store password, key pass, then the trust store path, password and the type. Okay. So with this configuration, we are setting up the key store. Okay. Now comes the final container that we need to run, that is the helper container. So in the helper container, if you see here, we need to pass the user. So user is root. So root means on Mac, root will have an ID as 0. Okay. So if it was some other ID, then this has to be changed. When I am saying it is a user ID as 0, then it must be root. Okay. So now this is for the which agent? It will be for the server agent. Now this is for the client agent. But with the same agent, if we are running 2 helper, then that will be contradiction. Usually we do not do it, but if you want to do, then we need to go with 2 separate users. Okay. Usually, like in a normal circumstances, that will not be a requirement. Okay. if some abnormal circumstances, if the requirement is there where you need two helpers with one agent, then you need to do some additional configuration where you need two separate users. But usually with one agent, we just need one helper, which will be mounting all the certificates. So here we are going with root, and here also it's root, but this helper is for another agent, this helper is for another agent, so there is no contradiction. Okay, so here we need to specify this main thing is this java SPIFFE helper server.properties file that will help the helper to establish the key store and also keep renewing and mounting the certificates automatically. Okay, so these things we have created here that I am referring to over here, and other like data required directories where it needs the data to start up this container. So if we run this last final container, then we should be good with running the whole architecture. Let's get started with running these commands and start the containers. So for your information, I have already started with the server. So I have already, let me just show you. So I already started with the server.configuration file, and I already started the server container. So we will start with the next steps. Okay, so here now let me just, okay, so we are done with the server part. So let's start with the tokens. Okay, so this is for the server. Let me just okay, I'll just make a note of it here. I'll just keep it so that we can use it for the further reference. So all these things can be automated, but I'm just doing manually. Okay, so this is for the client. I'm just copying and putting it here. Okay, so now we need to edit these two into the configuration file. Okay, so let me just do that. So if you have see, we have the same configuration, but let me just edit this. Let me just copy this part, and the token is like one-time use. You cannot use the same token again. So that's done for the server. Then let's do the same for the client. Okay, so here I'll just copy this. I for insert, then just use command V to paste it, escape, colon, write, and quit. Okay, so this will save the changes into the file. So I hope till here we are done with the configuration of the agents. So now let's start. Yeah, so the bundle out certificate is already created, so we do not, I'll not do this again. Next I'll start with the agent. This is the server agent. So here let's see whether the agent has started or not. Okay, so it is good, agent has started. So you can ignore these error messages. These are something which we do not need to worry about, but the agent has started. Let's do the same for the client agent. Okay, so yeah, we are good with the client agent as well. Let's get started with the workload. So here let me run this command. Yeah, but before that we need to change this token, right? So let me just copy the previous token which we have generated. Okay, then the one for the client and another one for the server. Okay, so now let's run this. Okay, so first workload is registered, that is server, then registered for the client. Okay, both are registered, so we can just do a check of that over here. So a couple of workloads will be auto-generated by the Spire server that are needed for its internal working. So the one which we have generated are, this is the one for the Java client, and another one is, this is the one that is for the Java server. The other are the workloads which are needed for the internal working. So next we can just run this command to check whether we are getting the certificates or not. Okay, so these are the SVIDs which we will be using to mount into the key store. So that will be done by the helper. Now we need to create these two helper.properties. So if you look at here, I have already created these two properties file. I'll be directly using that. So inside this properties file, I have this content. I'll be posting all this over the GitHub. You can just pick it up from there and just do a POC at your end as well. So yeah, let me now run the helper function or helper container. Okay, so helper has started. Let's check whether it's running correctly or not. So this is helper. Okay, it's good. Then let's start helper for the client as well. Okay, so yeah, good with the client helper as well. So these are the final 5 containers we'll be needing: Spire server, Spire agent for client server, Spire agent for client, helper for the server, and helper for the client. Okay, so now these are the things that are needed. Next, we should be good with starting our application that will be using the location where we just need to provide the location of the key store, and the automatic renewal and the creation of the certificates will be taken care by the helper. Okay, that we already discussed. So now let me take you to this. So here I have created 2 simple applications. So one is acting as a client, another one is acting as a server. Okay, so let me just give you a walkthrough of this. I just have a simple API that will be calling to the server from this application, that is server to server communication, where this is acting as a client and this will be acting as a server. Okay, so here and the configuration that we need to do, like this REST template configuration, where we need to inject the SSL context so that the communication happens with the server over the SSL. So here, as you see, I have just provided the location of the key store on this machine where the SPIFFE will, like the helper will mount the certificates. Okay, so that's for the key store, and this is for the trust store. Then I just added some logs so that we get some logs that how many keys or certificates are present inside the key store. Then here we are adding the verifier. Okay, so when you create a certificate, inside that there will be verifier. Using that verifier only, the client will identify whether, or the server will identify whether the request is coming from a authorized client or not. So here this ID should match to the whatever the ID we generated when we are creating the workload. Okay, so the same ID I have added it over here. That will be so this configuration will be sent to the server for client's verification. Okay, when mTLS is getting established. Okay, then here I am creating the SSL context. Then I am injecting this verifier into the SSL context, and finally adding it to the HTTP component client HTTP request factory. So this factory we are injecting into the REST template, and then using the same REST template to make the communication. Okay, so this part in the application can be different according to the requirement, but the underlying key store will be the same. The location of the key store will remain the same. So now from the application or from the development point of view, we do not need to worry about the creation of the key store and renewing the certificates. We just need to provide the location. It will automatically pick them up and use that. Okay, so that's from the client point of view. There is nothing with the application.properties. We just need to do configuration here if this is a client. Coming to the server, there are some extra configurations that we need to do. So here, first of all, nothing from the, no extra dependencies from the form.xml point of view, just a web dependency where we can create the REST API and to run the Tomcat container. But we need to do some other changes in the Spring Boot application. So this is a simple API that the client will be going to call. Next, here we have some as a service. So what is the purpose of this service? So this service is watching that watching this location where the key store and the trust store files are present. So the moment the helper renews the certificates or do some changes, so the application will automatically like reload the SSL context and put it into the application context of this Spring Boot. So why this is needed? Because the SSL context is loaded only at the one time at the runtime when you start the application, and it will load the key store and the trust store files, and it will be saved in the memory. So now after this start, if later at a later point of time, if the certificates get renewed, then the application will not automatically just get those and update the memory. So to update the memory of the application, we need to do some additional configuration. So here I have added a key store watcher that will be keep watching that location. So at any moment, if there is some update, so it will automatically reload the SSL context. So this is possible from, I think, some Spring version, I think from the 3.0, 3.2, from above 3.2 Spring version, SSL context can be reloaded. But for the previous version or for some other kind of application, you need to check. Like, I'm not sure on how to configure at that for those applications, but this is possible from Spring and from Spring 3.2 and above. Okay, so that is about it. So here I've added a watcher, key store path and trust store path. So this will be keep watching that location. So whenever there is some change, it will reload and inject that into the SSL context, reload the SSL context. Okay. So I'll be posting this entire code into the GitHub. You can just take a look at it. This is acting as a component that will be injected at the runtime when the application context is started. Okay. So that's about the, so here I have created a Tomcat bean that will be used to inject the SSL context at the runtime, like whenever we needed to renew it. I hope this is clear from the application YAML point of view. So we are enabling the SSL context, providing the key store location, password, type, alias, then trust store location, password, type, and this is an important thing where we are telling that once the server is authenticated, server will also ask the client to provide the certificates for establishing the mTLS, mutual transport layer security. Okay, I hope this thing is clear. Now let's get started with this application. Let me just start the server first. Okay, so we are good with the server. The server has started. Now let's start the client and let's check whether it's able to make the communication over the mTLS. Okay, so this output shows that there are one key store and one trust store present at this location, whichever location we have added it here, that is this location. So who brought these files? Helper has brought and put it at this location, and we are picking up from there. Okay, so now yeah, and then we are making communication over this mTLS. So now here this is acting as a client and this is a server. But now let's do a cross check. Let's test this. So right now here this client has the certificates, so that's the reason it is able to make a call to the server. When server asks like the certificate, it is providing it. But now let me just take this and try to send over the browser. Okay, let me just paste this. Okay, so as you can see what we are getting. So for this IP did not accept your login certificate, or may not have been provided. So this is the reason. That is, this client or the browser does not have those certificates to provide to the server when the server asks the client for the verification. So that is the reason this request is failing. But we are getting a successful response here when this client is sending the request, because this client has the certificates which it has got from the key store. Okay, so I hope you were able to understand this whole mTLS process, and about that you are also able to understand the SPIFFE architecture, how we needed to establish the different components and how they are connected. Okay, all I wanted to discuss in this video. So if you have liked this video, and if you want me to bring more such content on the technical topics, then please like this video, and please subscribe to the channel. And if you have any questions, then please post it in the comment section. I'll try to answer those. Okay, thanks a lot for watching.